So in this section, we are going to use the rules from the previous section to write different expressions without negative exponents. So first we're going to try to simplify them, especially if we have got fractions. We're going to simplify the numerator, simplify the denominator. And once we get something that's simplified with negative exponents, then we're going to get rid of those negative exponents. So let's start with number A. So I've got this. So what I recommend, once again, is just simplifying the numerator and the denominator first. So if I look at the numerator, there's a cubed, and there are no other powers of a. B minus 2, also same here. C. Now there's g to the 3 times g to the minus 3. So there's two ways to look at this. G to the 3 times g to the minus 3. Well, you could use the product rule, so add up the exponents. So 3 minus 3, that's g to the 0, and you see that g to the 0 is 1. Another way to look at this is g to the minus 3, that's the same as 1 over g to the 3. So g to the 3 times 1 over g to the 3, well, that's a number times its reciprocal, so that's 1 again. So there are two ways to look at this and see that this is actually 1. So this is just a cubed, b to the minus 2c times 1. So I'm not going to write the times 1. And below we have what? 2 d to the minus 1, e to the minus 4, f squared. So now I've simplified my numerator and my denominator. I'm now going to get rid of my negative exponents. Now, you'll remember that if I have something like a to the minus cube, that's the same thing as 1 over a to the cube. Similarly, if I have 1 over a to the minus 2, that's the same thing as a squared. Is that clear? 1 over a to the 2, that's the same thing as 1 over, you can see it this way also, a to the minus 2, that's 1 over a squared, and when you divide by a fraction, it's the same thing as multiplying by its reciprocal, so you do get a squared. So what I want you to remember here is that if you've got a negative here, if you bring it down, it becomes a positive. If you've got a negative here, if you bring it up, it becomes a positive. So the sign changes as things move from the numerator to the denominator. So I'm going to do this repeatedly. So a cubed, okay, power is the exponent is positive, so I'm going to keep it there. But b to the minus 2, it goes down because the power is the exponent is negative, so that's going to be a b squared here. C stays where it is. If I move down, well, 2, I kept it there. 2 d to the minus 1, it's going to go up so that its power becomes its exponent becomes 1. E to the minus 4 goes up, e to the 4, and f squared stays there. And I'm done. Okay, next example. Once again, I will simplify my numerator first. So there's 4. If I look at my constant, there's this, right? 4 times 3 to the minus 1. Now, at this point, I could say, well, 3 to the minus 1, I'm already going to send it down because it has a negative exponent. So I could already send it down here. Okay. If I look at the powers of x, I've got x to the minus 5, x to the 3, so that's x to the minus 2. And y to the minus 3 times y to the minus 2, that's y to the minus 5. And below I've got this. Okay. Now, what is this? Okay. I'm going to, there are different things I could do here. Maybe the easiest thing is to group like terms. So I've got, you see, so I'm going to do things slowly here. I've got 4 over 6 times 3. I've got x to the minus 2 over x to the minus 5. And I've got y to the minus 5 over y cubed. So I'm going to pair those up and simplify. Oh, I hope I'm not going to run out of space. Here we go. So this is not part of our solution. So 4 over 6 times 3. So 4, I could divide 4 by 2 and divide 6 by 2. So I get 2 over 3 times 3, and I can't simplify this some more. So this is 2 over 9. X to the minus 2 over x to the minus 5. So this is x to the minus 2. Oh, careful here. I'm going to subtract minus 5, right? So overall, that's going to give me x to the minus 2 minus minus 5. So minus 2 plus 5 is 3. And what do I have here? I've got y to the minus 5 minus 3. So that's y to the minus 8. And finally, I have one negative exponent, which is minus 8. So I'm going to send y to the 8 y down so that I end up with an expression without negative exponents. Now my last example, a bit more complicated. First I'm going to take care of my numerator. So maybe 3 times 6. I could multiply them. I could also say, oh, maybe I'll wait for that. I'll just regroup them because later on I want to simplify that with a 9. I could do that also right away if you want to. That's possible. But I'm going to do things slowly here. So if you want to, you can simplify 3 times 6 over 9. You see 6 and 9s are both divisible by 3. And 3 times 6 is 18. 18 over 9 is 2. So I know already this is going to be a 2. So I'm going to do that in a later step, but know that you can handle that right away. X, I've got x to the minus 2, x to the minus 6. So this is x to the minus 8. Y, like I said, it's easier to go about this in alphabetical order so that you don't forget anything. I've got y to the 5, y to the minus 2, so that's y cube. And for z, I've got z to the minus 3 times z to the minus 3, that's 1. So that cancels out. And now I'm going to take care of this thing here. So I've got in my base a product, and it's raised to a power, so I can distribute my, it's raised to an exponent, I can distribute my exponent to each of the factors that I find in the base. So x squared to the minus 3, so that's x to the minus 6. Remember, we're going to multiply them. And y to the minus 2 times y to the minus 3. If I multiply minus 2 and minus 3, I get 6. Okay. So I guess I didn't need to have a big, whoop. Okay. All right, so this is more compact. Now, like I said, 3 times 6, 18 over 9, that's 2. So you can simplify it in many ways. So ultimately, you'll get 2. If I simplify my powers of x, minus 8 minus minus 6, so that's the same thing as minus 8 plus 6, so that's minus 2 here. And y cubed over y to the 6, that's 3 minus 6 is minus 3. Like that. Okay. Now the power here, I'm going to distribute it to every factor I have in the base. So that's 2 to the minus 3. X to the minus 2 times minus 3 is 6. Minus 3 times minus 3 is 9. And I'm almost done here. The only thing I need to take care of is this 2 to the minus 3, which is, I can send the 2 to the 3 down. Or in other words, when you send it your power of 2 down, you're changing the sign of the exponent, and we could keep it like that, or sometimes we prefer to write our constants without exponents. So x to the 6, y to the 9 over 8, and that's our final answer. One thing to maybe notice about these problems is there are many ways in which you can simplify. So I prefer to simplify my numerator and then my denominator first, but you know, one could say, well, I'm going to distribute this minus 3 throughout every single factor that are in the base. That's possible too. I find that more messy and less efficient. So I've shown you essentially the way that I find the most efficient, but you can get to the answer in many different ways.